Hello students, today we will be solving the IB Math AA HL May 2025 paper 2 time zone 1 question number 9. You will be getting the solutions for the first 8 questions from this paper and the solutions of the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 9. The maximum mark is 6. Consider the differential equation dy by dx equal to 2x over x squared plus y. The solution curve passes through the point 1, 0. So part A's question is use the Euler's method with a step value of 0.25 to estimate the value of y when x equal to 2. It is carrying 3 marks. Okay, with the Euler's method, we can only give an estimated value of y. We cannot give the actual value of y when x equal to 2. Okay, and okay, let us start to answer this part A. For the Euler's method, the step value or the step size, this is given as, this is h, and it is given to be equal to 0.25. Okay, and the gradient function dy by dx is equal to 2x over x squared plus y. Okay, and we need to have the two formulas. We use the two formulas. Instead of writing n plus 1 and n, these are all iterative methods. So I write x, current value of x is equal to the previous value of x. Current value of x is xc is equal to the previous value of x, which is xp plus h. And the current value of y should be equal to the present value, the previous value of y plus the step size or step value times the gradient function, that is the dy by dx. And this should be a function of the previous values of x and y. So it is x previous, xp and yp. Okay. So let us modify these two equations because we know the h value, it is equal to 0.25. So therefore, xc, the current value of x should be equal to xp plus in place of h, it is 0.25. And yc should be equal to yp, the previous value of y, plus 0.25, and dy by dx, this is the expression for dy by dx, so it should be times by 2 times xp. Wherever there is x, we will be taking xp over xp square, x square, so it is xp square plus y, so it is yp. Okay, and now of course we have to use the calculator. So this is the calculator. We have to go to the spreadsheet, and this is the x column and this is the y column. First of all, we will be writing the given x and y values. These will be our current x and y values, the starting x and y values. Okay, the starting value of x is 1 and the starting value of y is 0. So it is 1 and this is 0. And now we come to the A2 cell. Okay, now we will be calculating the current value of x based on the previous value of x, which is 1. So xc will be equal to xp plus 0.25. Okay, so and we are using the formula, so we have to start with this equal to sign. xp, where is it stored? It is stored in the A1 cell. So I'll be writing A1. plus 0.25. The h value is 0.25, so it is 0.25. Okay, because xc is equal to xp plus h, and enter. 1 plus 0.25 is 1.25. And we have to get the value of y, the estimated value of y when x equal to 2. Okay, the current value of x is 1.25, so I have to get to x equal to 2. So I have highlighted this E2 cell, and you see over here the plus sign has appeared. I'm just dragging this till I get the x value as 2. I can drag it to more x values also. There's nothing wrong in it. So, okay, this is 5.25. I don't need so many x values. But, okay, I can keep them. You don't have to just delete those values. Okay. Now we come to the B2 cell. We will be getting the corresponding y values. What is the YC formula? YC formula is YC equal to YP plus 0.25 times this dy by dx expression, and in place of x, it will be xp, which is stored in the E1 cell. And for y, it will be yp, which is stored in the B1 cell. Okay. So we will be entering a formula. So we have to start with this equal to sign. Yp, it is stored in the B1 cell, plus h, it is 0.25 times. You cannot see the entire formula in this cell, but you can see it over here. You have to check whether you are entering the whole formula correctly or not from this part. Okay. And I am starting this bracket, and it is 2 times xp, so it is a1 over a1 squared x squared, so it is xp squared or a1 squared plus y, which is yp, so b1. Okay. See, b1 plus 0.25 times 2 times a1 divided by a1 squared plus b1, and enter. Okay. And now I'll be highlighting this, and this plus sign appears. So I'll be dragging this down. See, x equal to 2 gives the estimated value of y as 1.26, correct to 3 significant figures. Okay. So we have to, because it is carrying 3 marks, so it is better to give all the values. Okay. So let me just construct a table using GDC. X and Y. The starting values of X and Y will be 1 and 0. The next value is 1.25 for X, and the Y value is 0.5. Okay. I'll be writing all the other values also. So I have written all these values, and now I'm writing the final answer. Therefore, the estimated value of Y when X equal to 2 is 1.26, correct to 3 significant figures. Okay. So we have given the answer for the subpart A, subpart B, and the function graph is drawn. We do not know the expression for the function y equal to f of x, but this is the graph shape that they have given. Okay. And this is the gradient function expression that we have been given. and B is containing 2 further subparts. The subpart I is saying determine whether your answer to part A is an overestimate or an underestimate, justifying your answer. Okay, justifying your answer. So, and this part 1 and part 2 I and I together is carrying 3 marks. So, this will be carrying 2 marks and this will be carrying 1 mark. This is for just saying whether it is an overestimate or an underestimate, and second mark is for giving the reason. Okay, and you see for x equal to 1, this is the x equal to 1 point, and then we have just moved this way and we have got the different values of y. So for this section, I'm not taking this part. See, I'm not taking, you will be having x equal to 2 and corresponding y value, it will be a negative now. But I am not taking the portion which is below the x-axis. The calculator has given me portion of the y values which are positive, which are more than y equal to 0. Okay, the starting value is y equal to 0 and all the other values are more than y equal to 0. All are positive numbers. So it is this portion of the graph that we are considering. Okay, and for this portion of the graph, you see it is concave down. And whenever the concavity of the graph is downwards, the Euler's method gives you an overestimated value. Okay, this is the reason for your answer. The answer will be overestimation, and the reason will be because the graph is concave down. Okay, so BI, it is an overestimation, it is an overestimate. Because the graph is concave down. Okay, because what is Euler's method? How does it work? It takes different tangents because dy by dx is what? It is gradient of the tangent. We are starting at x equal to 1 and y equal to 0. So we will be drawing a tangent over here, tangent line over here. And then this is x equal to 1. Next point may be over here at x equal to 1.25. And we will be taking the corresponding y value. See, the tangent line is over here, which is above the graph. So the corresponding y value that the Euler's method will be giving will be the point which is on the tangent line. It will be reading the y value of the point which is on the tangent line. And since the tangent line is above the graph, so the y value will definitely be more than the actual y value. So this happens whenever the graph is concave down. The Euler's method will always be giving you an overestimated value. And the opposite thing happens when the graph is concave up. Okay. For this subpart BII, let me show you the question first of all. Justify why the use of Euler's method starting at 1, 0 does not lead to an estimate of the negative value of y when x equal to 2. That is what I was saying, that when x equal to 2, you will be having two values of y. One will be positive and one will be negative on the downside below the x-axis. Okay, so we had to say why is the Euler's method giving us the positive value of y and not the negative value of y. Okay, so for this I have brought in this graph once more, and as I have shown that at x equal to 1 we will be drawing the tangent like this maybe. Okay, and maybe this is 1.25. So we will be taking the point which is on the tangent. The tangent is moving this way. Okay, so if we have to get the point which is having its x coordinate at 1.25, I have to go above the x-axis. I cannot come below the x-axis. Okay, So therefore, again at x equal to 1.25, again we will be having another tangent. So it will be continuously moving up. Therefore, the y values are positive. We are not coming to the negative side at all. Okay. So that is why we are getting all positive values of y. So this is what you have to write. It is carrying just a single mark. For Euler's method, if a tangent is drawn at x equal to 1, it will be having positive slope, and then when we try to read the y value when x equal to 1.25, which is 1 plus 0.25, we move towards the right, and come to a point which has a greater y value than the starting point on the tangent. Okay. Since the starting value, since the starting y value is 0, therefore the other, all the other y values are positive. Okay. So this is what you have to write. It carries just a single mark. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon. In our next session, we'll be solving the next question, that is question number 10 of the same paper. Till then, bye.